Hey Shelby, so I just wanted to respond to your post really quickly. This word problem can be represented by a system of equations as shown here on this far left part, in which X would equal the price per gallon of inexpensive paint and Y would equal the price per gallon of expensive paint. Now there's a logical issue here because this second mixture here is more expensive than the first mixture here. Which doesn't make sense because the quantities of this second mixture is less than the quantities of the first mixture. Nonetheless, I can still show you how to solve systems of equations like you would have done for this word problem if the equations made sense. In order to solve for x and y of systems of equations, we can use different methods. One method is the substitution method and the other is the elimination method. Now, the substitution method we wouldn't use for this particular word problem because it's not as easy or applicable to use here as the elimination, but I still want to show you how to use the substitution method and when to use it. So in the middle part here, the substitution method is really good to use when you have a system with an equation that has an isolated variable. So as an example, we have this system of two equations here. As you can see, y is an isolated variable that has a value of 4. And with this method, you can easily substitute 4 for y in the other equation and then solve for x to find x. Another instance in which you could use this method and be very, very easy to use is when you have a variable with a coefficient of 1 or negative 1. So if you look over here, this system, we have two equations that are a little bit more elaborate, but this y value has a coefficient of 1, which means that we could isolate it really easily by subtracting 2x from both sides. And we have this equation y equals this expression here, okay? And then, using the same method, we can substitute this expression for y in the other equation. And then we have this new equation here, in which we just have x to solve for. And using the distributive property, solving the rest of it, x would equal 1. But we aren't done here. We need to find y. So we'd substitute 1 for any of the x values in these equations. I'm going to choose this equation over here because it's the easiest, and y would equal 2. So that's how you find x and y using the substitution method. If you haven't noticed, the system for this word problem is not like the examples we have for this substitution method. As you can see, for this system, there are no isolated variables or variables with coefficients 1 or negative 1. And if we use the substitution method for this system here, we'd end up with a lot of fractions. It'd be really messy and a lot more work. So we're going to use the elimination method instead. And I'm going to demonstrate the elimination method with this system over here. So pretty much the elimination method is us adding or subtracting both equations to eliminate one of the variables and end up with an equation in which there's only one variable to solve for. And when I say eliminate, I mean produce a coefficient of 0 for one of the variables. So as you can see, if we added or subtracted any of the corresponding coefficients for a variable, for example, x is 3 and 2, for y be 4 and 3, our outcome equation would not have any coefficients of 0. There wouldn't be 0x or 0y. So instead, we need to multiply the corresponding coefficients, 3 and 2 for x and 4 and 3 for y, by numbers that can change these coefficients to be the same number or a common multiple, so that you can subtract 1 from another and end up with a coefficient of 0 and cancel out the variable. So let's do a little demo. Let's choose any variable. So let's go with like x. Okay, and we need to find the common multiple of 3 and 2, right, for x. The least common multiple would be 6. So we are going to change both of these coefficients to 6 by multiplying this top equation, 3, by 2. And then we're going to multiply the coefficient of x here for this equation, 2, by 3. And using the distributive property, we're going to multiply the entire equation by these numbers. And then what we end up getting is this new system of equations over here. And as you can see, there is a common multiple here, 6, a common number that we can now subtract with. So we're going to subtract this entire bottom equation from this top equation. So we cancel this out over here. We subtract 9y from 8y and 21 from 20. We end up with negative 1y equals negative 1 over here, which would equal y equals 1. Now, once we have y equals 1, we'll use the substitution method. Substitute 1 for one of these y values from any of these equations. I chose the bottom one, as you can see here, and x would equal 2. So that's how you find x and y using the elimination method. So yeah, let me know if you have any other questions, and if you would like any tutoring, don't hesitate to reach out. Thanks so much.